Hello everybody, we're getting ready to do Algebra 2 Math, Lesson 1.1, Part 2. You want Part 3, email me here, and for other course material. We got a 1.1 Graphing Quadratic Functions Part 2 lesson today. We've got a 28-point sheet, and we have 2 points of note-taking today. So our first example 2 here, graph a function of the form y equals ax squared plus c. We want to graph y equals negative 1/2 x squared plus 3. Compare the graph with the graph of y equals x squared. So in this situation here, make a table of values for y equals negative 1/2 x squared plus 3. Here they are here. Here's the table for this quadratic. Plot the points from the table. So here we have a negative 1/2 x squared plus 3. Here's our parent function here, y equals x squared. We have a y-intercept when x equals 0, y equals positive 3. That's at our vertex. And then here are 2 other points that we plot from the table. Draw a smooth curve through the points and then compare it here to our parent function. There's our parent function. And both graphs have the same axis symmetry. However, this opens down and the other one opens up. And it has a vertex up here, not on the order. Okay, graph function. Compare the graph of y equals x squared, which is our parent quadratic. Students, you have this one here and compare it with the parent quadratic. So our guided practice here is a table of values for this quadratic here. So when we graph that, here's our parent function down here. We're way down here. We have a negative, and then our vertex, when x equals 0, y equals negative 5, is way down here. So this is what this quadratic parabola looks like there. Both graphs have same axis symmetry. It opens down and it's moved 5 units down from the parent function. Graph any quadratic function. You can use the following properties to graph any quadratic of this form here, y equals ax squared plus bx plus c, and function where b cannot equal 0. So a key concept here, classwork sheet page 5, properties of the graph of that form. Here they are here. Negative b over 2a will be the x coordinate of our axis of symmetry here, where a is greater than 0 in this situation here. So you know the parabola will go upwards when a is greater than 0. Then when a is less than 0, the parabola is pointed downwards. We know that much. So characteristics of this graph more. If a is greater than 0, opens down. If a is less than 0, the graph is narrower than the graph if a is greater than 1, and then wider if a is less than 1. And here's our axis of symmetry here. Negative b over 2a would equal the x coordinate for the vertex. And then the y-intercept is c, so point 0 c is on the parabola. That would be the y-intercept for c. When x equals 0, then c would be our y on a quadratic. So example 3, graph a function like this. Let's graph this one here. So identify the coefficients of the function. For a is 2, b is negative 8, and then c is 6. So since we know this is positive here, the parabola opens up. We know it opens up because 2 is positive, and the vertex, like the x coordinate for the vertex, negative b over 2a, so the negative of negative 8 over 2 times 2, and that would equal 2. Then find the y coordinate, so we plug 2 back into the original. Here is our y coordinate, so 2, negative 2 would be the point of the vertex. 2, negative 2, plot this point, draw the axis of symmetry. So the first step here is draw the axis of symmetry. 2, negative 2, we know this is the vertex. We also know that it goes up like this because a is positive, but here's the axis of symmetry. And then identify the y-intercept c. So y-intercept c would be over here, which is 6. When x equals 0, y equals 6. Plot the point. We plot that point. Then reflect this point in the x-axis. So we're 2 points to the left. We go 2 points to the right. So we have a point here, a point there. And then when we have our axis, we have our vertex down here. So basically, we have our 3 points here. Our x-intercept, that's something else all the different there. The function of their value of x, such as x equals 1. So when x equals 1, we have y equals 0. So we have this here. We go over 1. So we can go this way 1 now too. When x equals 2, we'll be at 0 as well. So wait a minute. When x equals 3 here, this will be 3, and then this is x equals 1. So we can plot these 2 points as well for our. Then plot the point 1, 0 and its reflection 3, 0 and the axis symmetry. That's what these are. Then we just go through and sketch it. Draw a parabola through the plotted points now, so we can sketch this. If you don't want to use your calculator, this is the way you do it. Okay, graph a function, label the vertex and axis of symmetry here. For this one, students, this is yours here, down here. So let's go ahead and graph this one here. Students, this is on you. We're going to graph this now. Graph the function, label the vertex and the axis of symmetry. We got our quadratic there. Negative b over 2a is 1, so we plug that back into the original, we get negative 2. So there's our vertex. We know it opens up. So when x equals 1, y equals negative 2. So there's x. What does that look like? Well, axis symmetry, x equals 1. Y-intercept is negative 1. So 0, negative 1. And then, see, when x equals negative 1, we plug that in. Then we get negative 1, 2. So we get this situation here going on here. Here is our y-axis. Here's our axis of symmetry. We got our y-intercept here. And then we move over. We know we're to the left one, so we go to the right one here. Plot that. And then over here, we just use when x equals negative 1, we get 2 here. So now we are 1, 2 to the left. We go 1, 2 to the right. So this is a way that you can plot, you can make a parabola by hand, is what it amounts to. And that was 1.1 part 2. Part 3 is available here. And thank you very much.